Good morning, children. Section formula part 2. In the last class, we have derived section formula and we discussed section formula is for finding the coordinates of a point that divides a line segment in a given ratio. The coordinates of the point P xy means to find the coordinates of the point P xy which divides the line segment joining the points ax1 y1 and bx2 y2 internally in the ratio m1 is to m2 or m1 x2 plus m2 x1 divided by m1 plus m2, m1 y2 plus m2 y1 divided by m1 plus m2. That means x coordinate of the point of division is m1 x2 plus m2 x1 by m1 plus m2, and y coordinate of the point of division is m1 y2 plus m2 y1 divided by m1 plus m2. And today we are discussing different types of problems related with the section formula and other two formulae which are derived from section formula. The other two formulae that derived from section formula are formula for finding the midpoint of a line segment and formula for finding the centroid of a triangle. First, let's discuss the different types of problems related with the section formula. There are a lot of different types of problems coming under section formula. Here we are discussing only the very important some of the problems among them. See the first one. To find the coordinates of the point of division. It's very important to know that in section formula, 4 measures are given. Among the 4 measures, the 2 measures are endpoints of the line segment, coordinates of the endpoints of the line segment, that means coordinates of A, coordinates of B. And the third one is the ratio of division. And the fourth one is coordinates of the point of division. Which are the 4 measures mentioned? 2 are coordinates of the endpoints of the line segment, coordinates of the endpoints. Here coordinates of A, coordinates of B. Second one is a ratio of division, and third one is coordinates of the point of division. Among the 4 measures which are mentioned, if we want to find one, we must be given with the other 3 measures. Okay. So suppose if you want to find the coordinate of the point of division, coordinates of the endpoint and the ratio of division must be given. If you want to find the ratio of division, coordinates of the endpoints and coordinates of the point of division must be given. And if you want to find any one endpoint, ratio of division and coordinates of the point of division must be given to us. In the first type, we are asked to find the coordinates of the point of division P. That we already discussed in the last class. And the second one you see, to find the ratio of division, we have to find the ratio of division m1 is to m2. In some case, instead of taking m1 is to m2, we will be taking it as k is to 1 also. Okay. So, since we are asked to find the ratio of division, we must be given coordinates of the endpoints of the line segment and coordinates of the points of division. This is the second case. First case, to find the coordinates of point of division. Second one is to find the ratio of division. Third one is to find one of the endpoints. In the third one endpoint A is given, coordinate of the point of division is given, the ratio of division is given, and we have to find the other endpoint of the line segment. These are the 3 types of problems coming under section formula. And let's see one more type of question also. The fourth one is to find the coordinates of the points of trisection. What is meant by trisection? Trisection is dividing a line segment into 3 equal parts. In this case, the line segment AB is divided into 3 equal parts by the points C and D. So very clear that if you want to divide a line segment into 3 equal parts, we need 2 points. In the case of line segment AB, for dividing it into 3 equal parts, the points are points C and D. That means here the points of trisection are points C and D. To find the coordinates of points of trisection means we have to find the coordinates of C and the coordinates of D. And here C and D are the points of trisection. That means C and D divides AB into 3 equal parts as AC, CD and DB. That is AC equal to CD equal to DB. So we can say AC is one part among the 3 parts and CB is 2 parts among the 3 parts. Okay, so for finding the coordinates of C, here you look, to find C, the ratio of division can be taken as 1:2. Why? Because AC is one part among the 3 and CB is 2 part among the 3 parts. So now here endpoints of the line segment A and B are known to us. Ratio of division is also known to us as 1:2. So certainly using section formula we can find the coordinates of C. In case to find D, what happens? Here is the point D. Ratio of division is 2:1. Why? Because this is 2 part among the 3 part and DB is 1 part among the 3 parts. So AD is 2 parts among the 3 parts, DB is 1 part among the 3 parts. So now we can find the coordinates of D using section formula. See, coordinates of the endpoints are given. Ratio of division is also known to us now. So we can apply these measures in section formula. Simplify, we will get the coordinates of D. This is another type of problem coming under section formula. Next are the formulae derived from section formula. We are going to discuss about, or we are going to derive 2 more formulae from section formula. First one is midpoint formula. The second one is formula for finding the centroid of a triangle. Midpoint formula. The midpoint of a line segment divides the line segment in the ratio 1:1. That everybody knows. Midpoint divides the line segment into 2 equal parts. So suppose AB is a line segment, and if C is the midpoint of the line segment, C divides AB into 2 equal parts, AC and BC, or AC and CB. Okay, so since it is divided into 2 equal parts, certainly ratio of division will be 1:1, isn't it? 2 parts are equal, so ratio also equal. So C divides AB in the ratio 1:1. So here we can consider M1 is to M2 as 1:1. Now A is the point x1, y1, B is the point x2, y2, and the ratio of division is 1:1. Substituting these values in the section formula, here you see section formula is m1 x2 plus m2 x1 divided by m1 plus m2. Y coordinate in the section formula is m1 y2 plus m2 y1 by m1 plus m2. So m1 x2 means m1 is 1, x2 plus m2 x1. M2 is also 1 into xn divided by m1 plus m2 is 1 plus 1. Similarly, m1 y2 is 1 into y2, m2 y1 is 1 into y1 divided by m1 plus m2 is 1 plus 1. 1 into x2 is x2, 1 into x1 is x1. So that is x1 plus x2 by 2, or x2 plus x1 by 2. Here 1 into y2 is y2, 1 into y1 is y1, m1 plus m2 is 1 plus 1, 2. So y2 plus y1 by 2. For the coordinates of the midpoint of a line segment are x2 plus x1 by 2, y2 plus y1 by 2. Or we can say it as x1 plus x2 by 2, y1 plus y2 by 2. That means if x1, y1 and x2, y2 are the endpoints of a line segment, then its midpoint is given by sum of the x coordinates divided by 2 and y coordinate is sum of the y coordinates divided by 2. That is x1 plus x2 by 2 and y1 plus y2 by 2. See, here C is the point x1, y1 and A is the point x2, y2. So, the coordinates of the midpoint of the line segment AC are x coordinate is x1 plus x2 by 2, y coordinate is y1 plus y2 by 2. So, add the x coordinates divide by 2, add the y coordinates divide by 2, or average of x coordinates and average of y coordinate. So remember, if x1, y1 and x2, y2 are the endpoints of a line segment, then its midpoint is given by x1 plus x2 by 2 and y1 plus y2 by 2. See one example. In this question, you are given the endpoints of the line segment. Suppose we can call it as point A and endpoint B. Coordinates of A are minus 2, 1 and coordinates of B are 5, 4. And M is the point that bisect AB, or M is the midpoint of AB. By the formula, what is M? What is the x coordinate of M? x1 plus x2 by 2 and y coordinate is y1 plus y2 by 2. What is x1? What is x1? x1 is minus 2, x2 is 5. So x1 plus x2 by 2 is, x1 plus x2 by 2 is minus 2 plus 5 by 2 and y1 plus y2 by 2 is 1 plus 4 by 2. Minus 2 plus 5 by 2 is 3 by 2, 1 plus 4 by 2 is 5 by 2. That is 1.5 and 2.5 are the coordinates of the midpoint of line segment AB. Okay. Next is find the coordinates of the centroid of a triangle with the given vertices. What is centroid of a triangle? Centroid is the line segment joining the medians of a triangle. What is the median of a triangle? Median is the line segment drawn from one vertex to the midpoint of the opposite side. In this case, in triangle ABC is given here. In triangle ABC, A is a vertex and opposite side of angle A is BC. Midpoint of BC is D. Okay. So median is the line segment drawn from A to D. And B is the second vertex and its opposite side is AC. E is the midpoint of AC. So BE is the second median. And C is the third vertex and AB is its opposite side. F is the midpoint of AB. So CF is the third median. So median is the line segment joining one vertex and a midpoint of the opposite side. And what about the centroid of a triangle? G is the centroid. And what is it? Centroid is the meeting point of all the three medians of a triangle, or the point of concurrency of the medians of a triangle. What is centroid? Centroid is the meeting point of three medians of a triangle. Now we have to derive a formula for finding the coordinates of G, coordinates of centroid. Before that, can you tell me what are the coordinates of D? Is it? D is the midpoint of line segment or midpoint of side BC, for the coordinates of B are x2 y2 and C are x3 y3. So certainly the coordinates of D will be x2 plus x3 by 2 and its y coordinate will be y2 plus y3 by 2. Let's see this in the next page. Here you see. The same triangle is mentioned here, triangle ABC. In triangle ABC, median AD only is mentioned. I have mentioned only the median AD. Triangle ABC with the vertices AX1 y1, BX2 y2 and CX3 y3. Okay, and median, one median drawn from the vertex A is also drawn and G is also marked. And the very important thing that we have to remember is centroid of a triangle divides each median in the ratio 2:1. Centroid of a triangle divides each of its median in the ratio 2:1. So in this case, median AD, in the case of median AD, G divides AD in the ratio 2:1. The larger part AG is 2 and the smaller part GD will be 1. So AG is to GD equal to 2:1. Okay. Now, what are the coordinates of D? Coordinates of D. D is the midpoint of the side BC. So, by midpoint formula, coordinates of D are sum of the x coordinates x2 plus x3 by 2 and y coordinate is y2 plus y3 by 2. We have already derived a formula for finding the midpoint of a line segment, midpoint formula. So, here the coordinates of B are x2, y2, coordinate of C are x3, y3. So coordinates of the midpoint joining those 2 points will be x2 plus x3 by 2 x coordinate and y2 plus y3 by 2 y coordinate. Remember, median AD is drawn. Coordinates of A are x1, y1. Coordinates of D are x2 plus x3 by 2, y2 plus y3 by 2, which we got from midpoint formula. And m1 is to m2. Ratio of division is 2:1. What is the reason? Because centroid of a triangle divides each median in the ratio 2:1. Keep it in mind. And see how the formula can be derived now. Now, from this triangle ABC, median AD, I have drawn the median along here. AD. Here, AD is the median of the triangle. I have drawn it as a line segment here. And see how can we derive the formula then? Means we are going to derive a formula for finding the coordinates of G or for finding x and y. So as I told you before, among the 4 measures mentioned in section formula, if you want to find one measure, the other 3 must be given. In this case, we have to find the coordinates of the point of division. So coordinates of the endpoints, are they given? Yes. Coordinates of A are x1 by 1. Coordinates of D are x2 plus x3 by 2, y2 plus y3 by 2. And the ratio of division is also should be given. That is given to us 2:1 because centroid divides each median in the ratio 2:1. Substituting all these, we can find x. What is x? We are finding x using section formula. X is m1 x2 plus m2 x1 divided by m1 plus m2. Here m1 is 2. This is m1 and this is m2. m1 is 2, m1 x2. In the place of x2, it is x2 plus x3 by 2. So m1 x2 is 2 into x3 plus x2, x2 plus x3 by 2. m2 x1, m2 is 1, x1 is, in the place of x1, it is x1 only. Okay. So in the next term, this 2 and 2 are cancelled. So what is remaining? x2 plus x3 plus this x1. x1 by 2 plus 1, here 2 plus 1 is 3. Writing in order, it is x1 plus x2 plus x3 by 3. So x coordinate of the centroid of a triangle is x1 plus x2 plus x3 by 3. Means sum of all the x coordinates divided by 3. Similarly, y is m1 y2 plus m2 y1 by m1 plus m2. m1 is 2, y2 is y2 plus y3 by 2 plus m2 is 1, y1 is 1 only. m1 plus m2 is 2 is to 1. Okay, so cancelling 2 as we did before, it is y2 plus y3 plus y1 by 3, or writing in order, it is y1 plus y2 plus y3 by 3. So y coordinate of the centroid is y1 plus y2 plus y3 by 3. So coordinates of the centroid of a triangle are x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. That means add all the x coordinate of the vertices, divide by 3, and add the y coordinate of the vertices, divide by 3. Okay, or the average of the x coordinate and average of y coordinates. You see, triangle ABC with vertices x1 y1, x2 y2 and x3 y3. x1 y1, x2 y2, x3 y3. So centroid of G will be here somewhere. Okay, G, centroid. Centroid of triangle ABC is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So study it well. Centroid of a triangle whose vertices are x1 y1, x2 y2 and x3 y3 are x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. And now we can go to the problem part. We are going to discuss 3 types of problems here. See the first problem, centroid problem we will be doing last. Okay. Find the coordinates of the points of trisection of the line segment joining 4, -1 and -2, -3. Points of trisection, we have discussed it. So for dividing a point into 3 parts, we need 2 points. See the figure. Case 1. What is case 1 and case 2? Why the case is mentioned like this? There are 2 points. For dividing a line segment into 3 equal parts, 2 points are there. So the case 1 is for finding the coordinates of P. Okay. For finding the coordinates of P, or before that, line segment AB. Line segment AB is divided into 3 equal parts by the point P and Q. 2 points. Okay. So AP is to PB is 1 is to 2. Do you remember we have discussed it before? Okay, so in this case ratio of division m1 is to m2 is equal to 1 is to 2. Okay, so x coordinate, now for finding the coordinates of P, we should remember only about P and forget about the Q. And we are going to find the coordinates of P. For finding the coordinates of P, A is 4 minus 1, B is minus 2 minus 3, and m1 is to m2 is 1 is to 2. So x coordinate of P are m1 x2 plus m2 x1 by m1 plus m2. Instead of m1 and m2, here m and n are all mentioned. Okay. So m1 x2, here by mistake a minus sign is there, children. That is not minus. m1 x2 plus m2 x1. So instead of m1 and m2, m and n are mentioned here. That doesn't matter. So m1 x2, that is 1 into x2 is minus 2 plus m2, 2 into x1 is 4. Okay, divided by m1 plus m2 is 1 plus 2. So minus 2 plus 8 by 3, 6 by 3 equal to 2. The same way y coordinate of P is m1 y2 plus m2 y1 by m1 plus m2, or my2 plus n y1 by n plus n. That also we can say, substituting m1 is 1 into y2 is minus 3 plus m2 is 2 into y1 is minus 1 by 1 plus 2. Okay, so minus 3 minus 2 by 3 is minus 5 by 3. So the coordinates of P are 2 minus 5 by 3. And next is to find the coordinates of the other point Q. For finding the coordinates of Q, you see, for finding the coordinates of Q, the ratio will be 2:1. Okay, finding the coordinates of Q, ratio is 2:1 because the larger part is 2 and the smaller part is 1. Okay, here x coordinate of Q are same section formula, 2 into minus 2 plus 1 into 4 by 2 plus 1, and I want to simplify. 2 into minus 2 is minus 4 plus 4 by 3, which is 0, and y coordinate is m1 y2 plus m2 y1 by m1 plus m2. 2 into minus 3 plus 1 into minus 1 by 2 plus 1, and simplify, minus 7 by 3. So coordinates of Q are 0, minus 7 by 3. So the coordinates of the points of trisection are, point P is 2 minus 5 by 3 and Q is 0 minus 7 by 3. This way we have to do the problems related with the trisection of a line segment. Now see, find the ratio in which the line segment joining the points minus 310 and 6 minus 8 is divided by minus 1 6. Here we are asked to find the ratio of division. Okay, ratio of division. Here line segment is there. A line segment, we can consider the line segment as A and line segment B, and the point of division can be taken as P, somewhere else on the line segment AB. We are given the coordinates of A, we are given the coordinates of B, and we are also given the coordinates of P. What are the coordinates of P? Coordinates of P are minus 3, 10. So the coordinates of P by section formula are m1x2 plus m2x1 divided by m1 plus m2. So substituting all these in this formula, or mx2 plus nx1 by m plus n also we can use, children. You practice with m1x2 plus m2x1 by m1 plus m2. Here it is written in m and n itself because the ratio of division is not given to us. We have to find the ratio of division. So instead of ratio like 2:1, 1:3, etc., it is not given, we have to find it. So replace the ratio, no need to replace, let the ratio as the ratio itself. So x coordinate of the point of division is 6m minus 3n, or 6m1 minus 3m2 by m1 plus m2, and y coordinate is minus 8m1 plus 10m2 by m1 plus m2. That means its x coordinate is given as, it is the point of division, not minus 310, minus 1 6 is the point of division. So x coordinate of the point of division is minus 1. So minus 1 is equal to, x is 6m minus 3n by m plus n, minus 1 equal to 6m minus 3n by m plus n. And on simplifying, we will be getting m1 is to m2 is equal to 2:7. Go through the simplifications very carefully. Okay. So we got, we need to depend either on the x coordinate or y coordinate. Here we have taken the x coordinate and find out the ratio of division. And the next problem, find the centroid of a triangle whose angular points are 4, minus 8, minus 9, 7 and 18, 13. Okay, angular points means the vertices of the triangle. And here the vertices of the triangle, if it is triangle ABC, if it is triangle ABC, A is here, B here and C here. Coordinates of A are 4, negative 8, B, minus 9, 7, and C, 18, 13. So what are the coordinates of the centroid? No need to draw a figure. You can directly write the formula and substitute. Okay. We know that the coordinates of the centroid of a triangle whose vertices are x1, y1, x2, y2 and x3, y3 are x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. In this case, x1 is 4, x2 is minus 9 and x3 is 18. So 4 plus minus 9 plus 18 by 3, and y1 is 8, y2 is 7 and y3 is 13. So y1 plus y2 plus y3 by 3 is minus 8 plus 7 plus 13 by 3. That means 13 by 3 and 12 by 3, which is equal to 13 by 3 and 4. So coordinates of the centroid of the given triangle are 13 by 3 and 4. x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So children, today we have studied two formulae. The formula for finding the midpoint of a triangle midpoint of a line segment whose endpoints are given. That is, if x1, y1 and x2, y2 are the endpoints of a line segment, then its midpoint is given by x1 plus x2 by 2, y1 plus y2 by 2. And the formula for finding the centroid of a triangle. If x1, y1, x2, y2 and x3, y3 are the vertices of a triangle, then the coordinates of its centroid is given by x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. Study both formulae very well together with the section formula. Study very well. Thank you.